Hello, this is Dr. Prasad Pudinam, continuing the class series BBOC407, that is for biology for computer science engineering stream students, CSE stream. So many streams are there based on computer science for them. Okay, so moving to the module 4. Module 4 has got these many topics: echolocation, bird flying, photosynthesis, Dr. sleep, etc. etc. So you can see. Okay, so in which the first part, the echolocation already completed. Moving to the second topic, that is bird flying, and how that is connected to the modern aircraft. Uh, what are the similarities and what are the technological advancements done comparing to that of a bird flying. The Bernoulli's principle, everything is comes under this topic. Okay, so describe the principle of bird flight and analyze how these principles have influenced the design of modern aircraft. Connecting to course outcome 1, level of question is 3 and it carries 10 marks. A description of principle of bird flight, 3 marks. Aerodynamic features wherein the bird fly the wings, that carries 2 marks. Analyzing on how bird flight principles are applied in aircraft design, that carries 3 marks. Then specific examples aircraft features inspired by birds, that carries 2 marks. Okay, so the principle of bird flight, which mainly consists of the lift, the thrust, drag, and control. So these are the terms which comes under the physics as well as in even aerodynamics. Uh, Aeronautical engineering students, they can also get benefited from this. Have deeply influenced modern aircraft designs. So by mimicking the aerodynamic features of bird wings, the feather, the body shape, the bone shape, based on that, engineers have developed more efficient, maneuverable aircrafts. Specific examples include the adaptive technologies like the winglets, high aspect ratio wings. Of all these improved performance by drawing the inspiration from the aviation flight mechanics. Okay, so coming to the first point, that is describing the principle of bird flight. The lift, first word lift, the principle behind that: birds generate lift to overcome gravity and stay aloft, means making them to be in the air. So it is because of the shape of the bird wings which creates the difference in air pressure above and below the wings, which produces that required lift. So additional information for that, that is Bernoulli's principle was introduced faster, means a bird didn't learn Bernoulli's principle. By seeing that bird's wings movement and the lift, Bernoulli made understood that concept and made a principle so that everybody can understand why he gave it so. So faster airflow over the curved upper surface of a wing, it lowers the pressure, while the slower airflow under the wing increases the pressure, resulting in a upward lift. So no, we no need to teach the birds about Bernoulli's principle. We need to understand. So if this is the wing structure, like wing structure in case of birds, so because of the shape of the particular shape, when it goes in the air, when air comes there, upper side, because of the shape, upper side more speed, faster air will be the downside, comparatively lower pressure. So that makes that airflow from suddenly that speed and up makes that wings to up. When wings goes up, along with that bird also it get lifted. So that is the Bernoulli's principle. The same technology it is being used in aeroplanes. Aeroplane wings are also of the same shape, similar shape. Okay, so that is Bernoulli's principle. Then the second point, that is thrust. Birds generate a thrust to move forward. The wings flapping provides the necessary forward propulsion. So thrust means to move forward. That flapping of wings by the birds creates the thrust, and comparing to that only the jet engines are being made. Okay, so it is the additional information. It is a muscle which is involved. The powerful flight muscles, especially the pectoralis muscle, that is indicated here. So this is the one which is uh, that muscle which is there in a bird, which drive the wings to down and back, propelling the bird forward. Okay, now the third one, that is drag. Drag means the resistance created in the air. So the birds must overcome the air resistance to fly efficiently. The mechanism used is a streamlined body shape which minimizes the drag, and the additional information that it is adaptation. The smooth feathers and that particular tapered body of the bird, it reduces the air resistance, and because of that they get better control. Birds need a precise control for maneuvering, adjusting the wing shapes, positioning, or the position allowing for the steering, climbing as well as diving. So the tail feather, have a tail feather which acts as a rubber, as a rudder. Rudder, that is in case of aeroplane, the backs being that is called rudder for getting better stability and control. Okay, so explanation for aerodynamic features in bird. I took a few images to explain that. So mainly the wing shape in case of bird, the aspect ratio. The birds with the long, narrow wings, they are having the high aspect ratio for gliding. Okay, while those with the short, broad wings, which is actually low aspect ratio, they are better suited for very fast, quick maneuvers. And campers, the curved shape of the wing, which camper increases the lift. So here some of the different birds like flycatcher, this swallow, the albatross, hawk, this different how that the wing structure, the difference in wing structure, it is indicated here. So that based on that, an aircraft or any airplane models can be prepared, mimicking that, and that only did by the researchers. They did mimic that one. Then feathers, they have primary feathers which provide the thrust during the downstroke. The thick feathers, when doing that flip flap, it gives the required thrust. The secondary feathers, they contribute the lift, and there is another set of feathers called alula. So alula, which is represented here. When a small, these are the small feathers structures on the leading edge of a wing that reduces turbulence during the slow flight. Okay, so this image represents the bird wanted to sit on a ramp, so slowly coming. So the alula is very active to reduce the drag. Okay, the turbulence. Now the low weight skeleton adaptation is the hollow bones of the birds, which reduce the weight without sacrificing the strength. The function lighter body aid in achieving and maintaining the flight. So the comparison is given, a human bone as well as a bird bone. That's why whatever we do, whatever we are not able to fly because our bones are having more weight, whereas birds bone are having hollow packages, air packages are there. Therefore, aeroplanes are also made similar to that. The structure, when they they are giving that consideration of that hollow type of structure for. Okay, analysis of how bird flight principles are applied in aircraft design carrying three masts. The lift and wing design. Airplanes have fixed wings as well as winglets. Aircraft wings are designed with a airfoil shape to create a lift similar to that of bird wings. The winglets are small vertical fins on the wingtip which reduce the drag and improve lift, which is inspired by the wingtip feathers of the soaring birds. Okay, so you can see what is that? This is the aeroplane without the winglets. So this is the winglets that we, even now when we do paper aeroplanes, the end of that we make a small that folding that also reduces the to reduce the drag. No, the drag or the vortex creation. The air which comes and cover, as when it goes fast, air will come and try to cover because the pressure region is varying. So to avoid that, the winglets are created. Winglets will avoid. So again, it is inspired by the uh, bird. Then thrust and propulsion, jet engines and propellers both have similar to that of birds. How they work is similar concepts has been used. Okay, so jet engines and a new modern jet engine is given here. So the engine part. So this is the engine part actually. Okay, engine is there in the wings actually. Earlier time it was propeller type. So you can see that big fan type. The propeller type was there. Okay, so the jet engine provided necessary thrust for a forward motion, which is analogous to the flapping motion of bird wing. And the propeller, it was early aircraft used propellers which mimic the circular motion of bird's wing flapping. That motion, the circular motion, whatever it makes. Based on that, propellers were made. Then that flip fast movement, comparing to that, analogous to that, the jet engines are created. Aerodynamics, the streamlined body, aircraft body, the fuselage. So the structure similar to that of the bird bone structure that is used throughout. That is called fuselage. Are streamlined to minimize the drag, inspired by the sleek tapered bodies of birds. Even the entire shape of our fuselage construction comes under. Then control surfaces, the ailerons, elevators, rotors. So better take the image. Okay, so you can see the ailerons, elevator, rotor, which are able to move, can read change role it for rotation, changes pitch up down, changes your side to side movement. For all those different movements, you can see the different parts. Every parts have, it can be made to move. So based on that, whatever the control the pilot does, the movement, the changes happens in this aileron, elevator and rotor, which makes the aeroplane to move accordingly. Okay, so which control movement similar to how birds use their wings and the back tail. Wings, in case of birds, they use that the back tail used to control. Same way in case of aeroplane, aerodynamics considerations are there. Now specific examples featuring inspired by birds: the wing flexibility, the adaptive wings. Modern aircraft are exploring adaptive wing technology that can change shape in flight, inspired by the flexible wing birds. Gliding and soaring, high aspect ratio wings are used for gliders. Winglets, reduction of drag, inspired by the birds. The upward curved wings tip of bird, like the condor. Winglets on commercial aircraft reduce drag and improve the fuel efficiency. And biomimetic, as such, mimicking, copying the birds, trying to copying the birds, which is called as micro air vehicles. So small bird-like drones which mimic flapping flights are used for surveillance and environmental monitoring. So that's about so a micro air vehicle images are given here. A simple one, or even a little bit more complicated ones are given here. So this is for the particular topic, that is bird fly, and how that is have been used to the aviation technology, and what are the different things connecting to aviation technology, what are the concepts on that. Based on that, computer science engineering students will get some, can be given some that's what I wanted to tell. Okay, so thank you very much for watching this video. Have a nice day.